Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11cc, Lesson 4, Measuring the Center of a Data Set. Now, when we answer statistical questions, right, we need to be able to have an answer. We need to be able to say something, right? And because statistical questions involve variation, we oftentimes want one number to be able to sort of summarize the entire data set. And today we're going to be looking at two different numbers that measure the center of the data set, a typical value within the data set. So let's get into those right away. As I said, when answering a statistical question, we often refer to one of the centers of the data set. A center is simply a value that is representative of all the values in the set, and the most common is what's known as the mean, but you've probably heard it called the average. All right, so what is the mean of a data set, right? The mean of a data set is just found by summing all the data values, just adding them all up, and dividing by the number of the values in the data set. All right, the average. I add up all the different numbers, all these different numerical data points, and then divide by how many of them there are, and that gives me the mean, or the average, of the data set. So let's take a look at one of those problems right away in exercise number 1. The high temperatures for the last week of April in Red Hook are shown below. Find the mean temperature for this week. Show your work. All right, so it's kind of annoying because we've got to take these 7 values and we've got to add them all together. That finds the sum of the data. And then we have to divide by how many there are. There's 7 of them. And then that will give us our mean. So I'd like you to pause the video right now and go through that process. The answer will come out as a whole number, okay? No decimals or anything like that involved, and see what you get. Take a few minutes to do that. All right, I don't know about you guys, but when I've got a bunch of numbers like this and I need to add them all together, I like to have them vertically stacked. So let me do that first, all right? I'm gonna write down my 59, my 61, 67, 60, 57, 65, and 72. Maybe give myself a little bit of extra space here. Extend the page a bit. All right, so here we go. 9 plus 1 is 10, plus 7 is 17, plus another 7 is 24, plus 5 is 29, plus 2 is 31. Carry the 3. 3 and 5 is 8, 8 and 6 is 14, plus another 6 is 20, plus another 6 is 26, plus 5 is 31, plus 6 is 37, plus 7 is 44. So our sum, and that's always the first thing that we do when finding a mean, our sum of all of these temperatures is 441. Now to find our mean, right, our mean is now going to be 441 divided by 7. That's oftentimes shown in fraction form because it's just simply easier to show that. But of course, when we do it, we're probably just going to do some long division here. 441 divided by 7. 7 goes into 44 6 times. That's a grand total of 42. Do our little subtraction. We get 21. 3 times 7 is 21. Subtraction and 0. So our mean, also known as our average, is 63 degrees. Now, notice a few things. Number 1, 63 isn't even one of those data points, right? The mean is very rarely one of the actual values in the data set. It can be, but it certainly doesn't have to be. But the idea is that if somebody said, hey, how warm was it that week? What was the high temperature? You could say, well, the average high temperature for that week was 63 degrees Fahrenheit. Right? And that kind of summarizes all the temperatures. Some of these temperatures were below the 63, some of them were above the 63, right? And the 63 was a nice center value. All right, let's work a little bit more with the mean to try to understand really what it's telling us. In other words, how can we interpret the value of the mean? Let's take a look at exercise number 2. Kevin and his 2 friends compare the amount of tickets that they have each won at an arcade. The 3 values are 62, 79, and 84. Letter A asks us to find the average number of tickets the friends have. Show your work. All right, so you've probably all been to an arcade, right, where you're playing games or, whatever, and you get all those tickets that kind of come out. In the end, you go up and you redeem them for, something that would have cost you 75 cents at a local store. All right, right, and we've got these three values, and I want you to find their average. So this should be pretty quick. You just simply have to add the three values together and divide by 3. Why don't you pause the video now and go ahead and do that. All right, so simple enough. Let's do it. Again, just like before, I'm going to write down my 62, my 79, and my 84. Add them all up. 9 and 2 is 11, plus 4 is 15. Carry the 1. 6 and 1 is 7. 7 and 7 is 14. 14 plus 8 is 22. All right, so that's my sum, right? That's all of my tickets. And then I'm going to do 225 divided by 3, 7, 21, subtract 15, 5, 15, subtract 0. All right, so the mean would be 75. The average number of tickets that the three friends have is 75. And again, wasn't one of those data points, right? It's just sort of a central value. Now let's take a look at letter B. The boys decide to share their tickets with one another so that each has the same number. How many do each have? All right, we'll pause the video now. Think about this. How many would each of the friends have if they shared all of their tickets together evenly? Well, they'd have 75, right? I mean, think about that for a moment. If we didn't have this idea of the mean at all, if we hadn't been talking about it, if you had just kind of gotten this problem, the kids have 62, 79, and 84 tickets, but they want to divide them amongst themselves so that they each had the same number, what you would do to figure that out is exactly what we did to figure out the value of the mean. You would add up all the tickets, find out how many total there were, 225. Then you'd divide by 3 to see how many each one of them had, right? And then that gets us into how we want to think about the mean. Let's take a look at exercise number 3. Why would it make sense to think of the mean as the equal or fair share value of the data set? All right, so this is important terminology. It's the equal share or the fair share value of the data set. Why does that make sense? Well, it makes sense because literally, to find the mean in any situation, we add up all of the numerical data, right? We find the total, and then we divide by how many subjects there are, right? And so it's really the amount that each subject would have if the total was distributed evenly, equally, or fairly, right? So it would be the, I'm going to put this in quotes, the amount each subject would have if the total was divided equally or fairly amongst them. Right? Now, in the cases of those tickets that we looked at in exercise 2, that makes all the sense in the world because you can literally add all the tickets together. You could, like, all three friends could throw them into a pile and then they could divide them up equally between them, right? It makes less sense if you were, like, let's say, measuring the heights of all the people in a class. You can't divide out the heights equally, right? But you could still think about it that way, right? If the average heights of all the students in, let's say, some 6th grade math class was 50 inches tall, right? It could be that every single person in the class is 50 inches tall, but more likely it's that if you threw in all the heights into the middle of a pot, added them all together, and then divided it out so that everyone was the same height, they'd all be 50 inches tall, right? And you'd still get the same sum. So the mean is simply what happens when you divide out the sum total evenly amongst all the subjects. What would they have? What value would they have? All right, let's take a look now at a different measure of center. So the mean is undoubtedly the most common measure of center, but there's another one that comes up a lot as well, and that's known as the median. So the median of a data set, aka the middle. The median of a data set is found by finding the middle number of a data set if it's got an odd number of values and they're arranged in order. All right? So in other words, if you take all of your data and you arrange them in numerical order and you grab the number that's right in the middle, right? Talk about a good thing to think about the center of the data set, right? Then that number is known as the median. And there will always be a middle number if there's an odd number of data points. Now, on the other hand, if there's an even number of data points, there isn't some number right in the middle, but there are two numbers that are mostly in the middle, and you find then the median by finding the average of those two numbers, or the mean of those two numbers. So let's take a look at how the median plays out in exercise number 4. Each of the following data sets has been arranged in order from the lowest to the highest. That's called ascending order. If they were highest to lowest, it would be descending order. State the value of the median. Show how you found your answer. All right, so let's take a look. In letter A, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. Oftentimes we do not algebra, but just we represent that with, not 7. 7 and 9 aren't the same. 9 data points, right? And because there are 9 data points, right, what that means is that there will be one number in the middle. Now, one way that people will find them is they'll literally start crossing off data points from the beginning and end. In other words, those two kind of get crossed off, those two, those two, those two, and there's your median. Now, that works fine enough. It gets a little messy though, especially if you have to do more work with the data set afterwards, right? A lot of times what I'll do is I'll simply just sort of think about it. I'll think, well, if I've got 9, right, there'd have to be sort of 4 below, 4 above, and then 1 in the middle, right? 4 and 4 is 8, plus 1 more gives me my 9, okay? So my median there, my median is 17. Now, on the other hand, right, data set B has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Long reach. It's got 10 data values. All right, so there is no central number. But what I can say is I can say 1, 2, 3, 4, 5, right? And 1, 2, 3, 4, 5. Like literally that vertical line kind of divides the data set into the lower 5 and the upper 5. And now what I'm going to say is I'm going to say my median now is going to be the average of those two numbers, which is going to be 48 divided by 2, which is 24. Now, before we move on, I just want to point out something that may be obvious to you, all right? When you're averaging just two numbers, just two, which is going to be the case when you have this kind of situation going on, you're really looking for the number that is halfway between those two numbers. The average of two numbers will always find the midpoint number, or the number that is the midway between those two. So if you think about 22 and 26, it's pretty obvious that the number that's halfway in between them is 24. And I only say that because for some of you, you wouldn't, if you realize that, you don't really have to show this calculation. You say, well, I got 22, 26, the number that's halfway between them is 24. If I had like 22 and 23, the median would be 22.5. So we can definitely have some decimals going on here. Okay, no doubt. But the weird thing about the median, unlike the mean, is that the way that you figure it out really is different, you know, whether you have an odd number of data values in your data set, in which case it is definitely just the middle number, or an even number of data points in your data set, in which case it's the average of the two most middle numbers, the two numbers that are most in the middle. None of that sounds right. Anyway, let's keep going. The median and the mean values of a data set are rarely the same, but they are often close to each other. In fact, the most interesting things in statistics happen when they're not very close to each other. Let's take a look at exercise 5 just to get a little bit more work with both the mean and the median. Camilla asked 5 of her friends how often they rode the subway this week. She recorded the following observations: 3, 5, 6, 9, and 12. Letter A, what is the median of this data set? And letter B, what is the mean of this data set? All right, so I'd like you to pause the video and answer both letters A and B, find both the median of the data set, I think that'll be pretty quick, and find the mean of the data set, that'll take a little bit longer. Pause the video now. All right, well, the median is super duper simple, especially when you have five data points, right? 5 data points is simply because the median's right here, right? You've got your 2 below the median, you got your 2 above the median or the middle number is 6. The mean always takes a little more work, right? The mean always takes a little more work because you got to add them all up. Now this time, because the numbers are relatively small, I'm just going to do the sum without stacking them vertically. I have 3 plus 5, which is 8, plus 6 is 14, plus 9 is 23, plus 12 is 35. So the mean now is going to be equal to 35 divided by 5, which is equal to 7. And so what you see, right, is that these 2 measures of center are similar to each other. They're close to each other, but they're not exactly the same. So if Camilla was trying to get a sense for, a good number to represent how many times her friends rode the subway, she could say, well, on average, they rode the subway 7 times, but the median number of times they rode the subway was 6 times, right? Again, similar values, right? Only differ by 1 unit, right? 1 subway ride, but not the same. Again, they can be, but in this case, they weren't. Okay, so we now have 3 measures of center: the median, the number right in the middle, the mean, which is that fair share or equal value, and the mode, which we saw back in lesson 1 of this unit. And remember, the mode is simply the data value that shows up the most often, okay? So let's take a look at one more problem with mean, median, and mode, exercise number 6. A group of 8 people at a movie theater were asked their ages. The data is shown below: 7, 8, 10, 12, 18, 21, 22, 22. Find the median, the mean, and the mode for this data set. Are any of them the same? Okay, so take a little bit of time. I think probably both the median and the mode will be quick. The mean will take a little bit more time. So pause the video and take as much time as you need. All right, well, let's do the median first. Let's just go right down the line. The median, simple enough. Now it's 8 people. So because there's an even number of people, what happens is that there's a lower 4 and an upper 4, right? So you got the lower 4 ages, you've got the upper 4 ages, and the median is now going to be the average of these 2. Now for some of you, again, it'll be obvious that the number that's midway between 12 and 18 is 16. But if not, you simply add the 2 together and divide by 2. I don't know why I said 16. That was weird. It's actually 15. So the median is 15 years old. Apparently for some of us, it's not obvious. Let's now do the mean. The mean, of course, takes a little bit more work. Maybe I'll do the sum over here. I'm gonna write down these ages in this order so that I can add them all up. All right, if I want to sum these, 2 and 2 is 4, plus 1 is 5, plus 8 is 13, plus 2 is 15, plus 8 is 23, plus 7 is 30. 3 and 2 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10, plus 1 is 11, plus 1 is 12. So our sum is 120. Let me write that down. Our sum equals 120. So our mean will be 120 divided by 8. 1, 8, subtract 4, 15, right? So our mean now is 15. We should make sure we label. Oh, there are two that are same, right? So right now we know the median is 15, we know the median is 15, and we do have a mode, just barely, but we do, right? The one that showed up the most often was 22, and that was our mode, right? So the mean and median are equal. All right. There are occasions when all three can be equal. All right. Honestly, the mode is probably the least interesting of all the measures, but sometimes it could be interesting. Do you know what I mean? You could have a situation where maybe you have a birthday party or something like that, and almost everyone there are like people who are 12 years old. Let's say it's a 6th grade birthday party. Almost everyone there is 12 years old, right? And that's the mode, 12. Right? But maybe there's some random other people that make the mean and the median a little bit different than that mode. But most often when we talk about measures of center, almost always we're either going to be looking at the median or the mean. The mode is of way less interest. It tends to be. All right. So when we answer statistical questions, and statistical questions always involve variation, almost invariably, our answers are going to involve a measure of center, one number that can summarize the entire data set, right? One number. The most common of those is the mean, the average, where you add up all the numbers and divide by how many there are, right? To sort of find out how much each one of the subjects would have if the total was sort of divided evenly or fairly between them. The other very, very important measure of center then is the median. And that's the number that's going to lie right in the middle of the data set, right, if the data is arranged in order. And we're going to see the mean and the median a lot more in this unit as we move on, and you'll see them no matter how many stat classes you take. You could be taking stat classes in graduate school. You could be in med school and you're going to be seeing the mean and the median, okay, because they are such important measures when answering statistical questions. All right, well, that's it for now. I want to thank you for again joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.